are rolling in. This is being recorded, so if you hop in late, the webinar will be available on demand after the event. But I would like to welcome you to the first of many of today's webinars, the Continuous Software Pipeline, CI/CD meets Continuous Packaging. I am Nick Rycar, Technical Product Marketing Manager at Buildkite and your MC for today's fun. And I am joined by Ciara Carey from Cloudsmith. Go ahead and say hello.
Hi.
I'll be pretty quiet on this webinar. I got a little bit of house cleaning up top and a slide or two to show you if you'll indulge me, and then I will pass things off to our wonderful guest. But let's go ahead. And give you a little bit of an overview of what Buildkite is. If you're here, you probably have some idea, but to give you the high level, Buildkite is a platform for running fast, secure, and scalable continuous integration pipelines on your own infrastructure. It embraces a hybrid SaaS CI/CD model where we provide our customers and users the convenience of a hosted platform where you can get insights and set up your pipelines from a web UI hosted by Buildkite, combined with the security and flexibility of being able to run builds behind your firewall. So our agent runs in your own environments where you can go ahead and make sure they mirror production as closely as possible, and you do not have to upload any of your code to our servers. And with that, we'll talk about one of the important concepts when you're doing CI/CD, and that is, where are you going to keep the artifacts that you're producing? And so with that, I'm going to turn things over to Ciara and talk about Cloudsmith and packaging up apps for the cloud.
Hey, so I'm going to start by sharing my screen. Hey, you guys can see that?
Coming through on my end, and I'll watch the Q&A.
Okay, great. Okay, so my talk today is on continuous software pipelines. CI/CD meets continuous packaging. So today we'll be covering package management in software development, continuous packaging, and how it relates to CI/CD. I'm going to go through a really simple demo of how Buildkite works with Cloudsmith. And then I'm going to show you one of Cloudsmith's features. It's multi-format repositories, and it's a real differentiator compared to other package management solutions. And then I'm going to open the floor for questions. Hey, so I'll just introduce myself. I'm Ciara Carey, and I work in developer relations in Cloudsmith. I started working in Cloudsmith in May, and prior to that, I was a software engineer for over 10 years, since like the late 2000s. I worked as a backend engineer, mostly on web apps and web services and security products and printing apps. And earlier in my career, I was a vision system engineer working on computer vision applications. So I've worked on loads of different languages and frameworks and tools, like including NPM and Python and C#.NET, and with the vision apps, C++. So I think my background gives me a lot of empathy for developers, because like I've had to go through it too. So about Cloudsmith. Cloudsmith is a fully managed package management as a service, and it was founded in 2016 in Belfast in Northern Ireland. So it enables your team to quickly set up private and secure delivery pipelines in minutes. Cloudsmith is a universal package management service that supports most package formats, like over 25 formats, and it can be used for software development, software deployment, and distribution of your software. Cloudsmith want to be your single source of truth for all your software dependencies and the information around that. It helps you isolate, protect your teams and customers from supply chain attacks. So since I started working as a software developer in the late 2000s, there's been like loads of changes, and I want to go through some of the biggest influences on those changes over those 10 years. So I think the biggest change has been in software development over my time is the availability of cloud infrastructure and that movement away from data centers. This has changed how we develop software and what we developed. This has driven the use of SaaS products, new software patterns like microservices and containers, and it has introduced new problems like container orchestration, scale, distribution, and security in the cloud. Another huge change over this time has been distributed teams. They've always been quite common in software development, but COVID has supercharged its adoption, even in small companies. So we don't just have distributed teams now, we have like distributed individuals. Devs need tools that can handle a distributed workforce, giving everyone super fast access. Another huge change is automation, the rise of DevOps. You guys all are here at a Buildkite conference. You know all about automation, CI/CD, automated pipelines, and how it can improve the quality of your software and increase the speed that you develop software. Developers are demanding good quality tools to help them automate their software pipelines. And another huge change, especially in package management, and has been the emphasis on supply chain security. So your supply chain are all the steps that go into developing and deploying your software. It includes your code, your third-party dependencies, your scripts, your tests, your environmental variables, your IDEs, your plugins, source code repositories, your CI/CD tools, and your package manager. The attack surface for software supply chain is vast, and recent attacks on SolarWinds, CoCov, and attacks on public repositories have promoted efforts to improve security of your software supply chain. So I think we can say that software development is really complicated. Developers have to make loads of choices about what to code, what kind of software patterns you're going to use, whether to use dependencies or to write it yourself, and what dependency to use for that when you've decided to use a third-party code. And devs have to use lots of tools, and there's been an increased emphasis for to shift left with quality and security, and this puts an awful lot of pressure on developers, which is a bit unrealistic, I suppose. So in this complex space, developers need tools to help them build software fast and securely. Software teams are moving away from slow, brittle, and on-prem DevOps tools that are unsuited to modern software development and distributed teams. We all know these tools. They were great 10 years ago, and they really helped us automate our pipeline, but they're not really suited to sort of our modern day concerns. Tools like Cloudsmith and Buildkite can do that for us. And these tools need to be cloud native. Developers don't want to worry about infrastructure, patching, upgrades, replications, or scaling. They want to use SaaS tools with high availability and be managed and accessed on the cloud securely. In order for DevOps tools to exploit the flexibility, scalability, and resilience of cloud computing, it needs to be architectured to be cloud native. So we also need tools that you can automate against easily and integrate with other tools. We need good APIs, a CLI, webhooks, and good documentation to show us how to use the tools. The tools need to have security features by default, like 2FA and single sign-on. You need to have good policies backing up your application, and you need to have analytics and metrics to show how the tool is being used. You need to also integrate nicely with security tools. So Cloudsmith has actually recently achieved ISO 27001, so which is really great. It just happened. So also clouds tools need to have good quality support. Support is really important to Cloudsmith, and for us it comes from our exec team. It comes from the top. I know Buildkite is really similar, but it's actually easier for tools like Cloudsmith and Buildkite to provide quality support. We don't, like for Cloudsmith, we only have one tool running on our infrastructure. Other tools that are on-prem tools that are out there in the wild, they have to look after all the versions of their tool, and they need to account for all the different infrastructure that their tool is running on, making it really difficult to have good quality support. So it's actually, by being cloud native, we've made it easier for ourselves to provide good quality support. So Cloudsmith is a package management solution. We're a package repository. So I wanted to talk about terms we use in package management that we just throw around. So first we have our package, or like you might call it an artifact or an image. These are like the package groups together all the files in your software, along with your metadata and your dependencies. And these are all in a well-defined format. So you might want, metadata is any information about your package, like the checksum, the version, who wrote the code, and you can actually add extra information to that, like information about your CI/CD tool, like what tests passed or failed, what are the results of vulnerability scanners, loads of information about your package. And a dependency is if your package uses another package, that's a dependency. A dependency can be an in-house dependency, like a library that you're pulling in, or it could be a third-party dependency found on open source repositories. A package manager is software that is used to create, upload, install, and upgrade and configure your software packages. I've created a table here of a few examples of package formats and their corresponding package manager. Ooh. Oh no, that's okay. So Debian RPMs, they use apt-get as their package manager. Python wheels use pip as their package manager. And Maven, which is Java, has a choice of a few different package managers. So we have like Maven, Gradle, or Ivy. And the reason why you might choose a different package manager is because you might prefer the way it configures your package. It might give you a different way of managing dependencies, or it might just be quicker. So let's talk about package repositories now. So a package repository is a place where you store your packages. So all your output from your Buildkite or your CI tool can go into a package repository. We have two kind of main types of package repositories. We have the public community-based repositories like PyPy for Python or NPM registry for Node packages. And community-hosted public repositories have made publishing and consuming packages really easy. The ease of use has made them really popular and has accelerated the development process and the use of open source software. I think most organizations pull in some open source software that are housed on these public repositories. There has been some security issues as well that go along with this. By having this kind of third-party code, bringing that into your code base does have security implications. So I'll talk about private repositories like Cloudsmith. So many organizations need a private repository for their packages for security, compliance, availability, reliability, or they might need to store many formats because public community-based repositories generally store one format, like the Node registry just stores Node packages, Python just, so on and so forth. On top of that, private repositories provide additional features required by enterprises like access control, single sign-on, guaranteed uptimes using SLA, strong integrations with other tools, custom domains for distribution, or they might want data analytics. So what you can take from this slide is that packages are created using the package manager, and they are usually stored in a package repository. So modern package repositories need to host many formats. So I'm going to talk about this for a little minute. Cloudsmith, for example, we support over 25 different formats. And even though each package more or less does the same thing, and each package manager more or less does the same thing, there's a huge amount of variability. This matters less when you've got one package format to manage. But if you have more than 10, which is not uncommon in a tech stack, it gets very complicated. And you need an effective abstraction layer around managing that process in a uniform way. So modern package repositories need to be the single source of truth. We talk about this a lot in Cloudsmith. We want to be the place where we store all your software artifacts. We have all the dependencies associated with that, those packages, and all the data related to it in metadata. Modern package repositories need to be easy to automate against with strong APIs, CLIs, webhooks, and good integrations. They need to have security by default and manage the problems of scaling and distribution. So modern package repositories need to blend package management and the software supply chain management. So the next part of our talk, we're going to talk about securing the software supply chain using a Cloudsmith and Buildkite. And we're going to talk about how to create that chain from CI to CD, how to bring that information from CI to CD. So Cloudsmith has coined the phrase continuous packaging to describe the blend of package management and software supply chain management. Continuous packaging, or CP for short, is about owning the creation and consumption of packages end to end. It's central to software supply chain management, and CP practices prevent you from dropping the ball between building your software and deploying your software. CP goes hand in hand with the ethos of modern DevOps practices to automate everything, to build frequently, and end-to-end responsibility of the software process. So Cloudsmith really want to elevate CP to the same level as CI and CD. Adding CP to your software process surfaces and enriches the package metadata, which describes your package and makes it audible, gives you a history of a package, and you can use that to build trust on the package. Call that kind of provenance. You probably heard that in secure software development supply chains. They talk about provenance a lot. So we also improve the visibility of what software packages are being used, including your dependencies, and gives you control over your packages and its dependencies, because we have the single place to manage that. It avoids the ad hoc construction or retrieval of assets across all package types. And CP means that assets are always traceable, deployable, and built in the same way. So we like to say CP is the glue between CI and CD. And here's like an image of like a possible pipeline that does CI, does CP, and does CT using Buildkite and Cloudsmith. So what does that look like in practice? What does continuous packaging look like in practice? Well, with Cloudsmith, we see this is how we implement continuous packaging. The first thing is that we host all your packages in any format in one location and make it accessible across the whole organization. You can add upstreams for external dependencies, and you can cache the dependencies from the upstream that your packages use. Next thing is we sign every package you push to Cloudsmith. And so, and then you can check the signature and check the checksum on that package. And for increased trust, you can provide us with your own key for signing or a sub key, depending on what you do. And we'll manage that for you. So the next thing we do to implement CP is to extract and enrich package data. So we take all the package data from packages when you're pushing it up. We'll take it all out, like what version of package that is, what license is used, the checksums, who wrote the code, the dependencies, the build date and time, the tests that have passed and failed. You can enrich it with this information, results from vulnerability scanners, and you can add any custom data that's important to your CI process. This is like package metadata, like I've talked about before, and it's vital the package metadata isn't lost or difficult to extract. And Cloudsmith makes it auditable. Yeah. So Cloudsmith does this using universal tagging. It surfaces this information and makes it easy for you to automate against. When a package is pushed to Cloudsmith, tags are automatically generated for that package, like file type, architecture, and other information. And this default package information can't be removed or modified. In addition to this, you can add any custom tag or to any package or container, either during package upload or after the fact. And then you can use these tags to search against, or you can use, we use entitlement tokens for to share packages to third parties. And you can associate the tags with these tokens to limit the packages that your customers can access. You can also search using these tags, and we have a full Boolean search for this. And you can manage your custom tags using your CLI or API or via the website. So also to implement CP, Cloudsmith is your single source of truth. It brings all your packages together, all the dependencies and all the information about the packages in one place. You can then visualize, control, and observe what happens to these packages from one place. So, and this image here is just like a Cloudsmith repository, and I've clicked on a Docker image here, and you can see the signature information is visible. You can see the version number, and if you click on the other tabs, you can see it's a Docker image, so you can see actually the layers in that Docker image. And also for Docker images, we actually provide a vulnerability scanner, and you can see the results of that scanner. So 3 things to sum up continuous packaging. We like to say provenance, isolation, and acceleration. So provenance, CP can secure your packages by surfacing and enriching the information to help you trust the provenance of a package. And isolation, so a lot of software you run is built by someone else. We talked about community public repositories before. This is a possible channel of attack, and Cloudsmith allows you to cache those assets and vet them before promoting them to production. And acceleration. So distributed teams are here to stay. We need to implement a package management on a global scale, providing each team with optimal experience. So every team member should get like super fast times and low latency performance. So now I'm going to go through a really simple demo with Buildkite and Cloudsmith. And I'd like to thank Buildkite because I just forked their projects up on their public GitHub site. And I just basically added like Cloudsmith push. It's really easy to use Buildkite and Cloudsmith together. Okay, so I'm going to show you an empty Cloudsmith repository. You can set up a repository in like 30 seconds, I think we say, but just in case I've already done this. So we have an empty repository here. I'm going to show you my GitHub project. This is a node one that I forked from Buildkite. Thank you again. And they had already provided a pipeline YAML file to describe the steps in their pipeline. So what I did here is I've installed the Cloudsmith CLI in one of the steps. And then I have installed and packaged my npm package. And then I've used the Cloudsmith CLI to push the created package to Cloudsmith. So you would probably separate out all these steps, but it's a demo. So, and then if you were separating out these steps, you would use Buildkite's temporary artifact storage and before you pushed it to Cloudsmith. Okay, so I have my Buildkite agent just running locally. Yay. And I'm going to go into my Buildkite pipeline. I've set this guy up here with my node project, and I've already done that. and it automatically picks up my pipeline file and runs the steps. It's really great. So I'm going to leave it running here, and I'm going to show you quickly a Cloudsmith repository. Okay, so we have an empty Cloudsmith repository here, and I can upload a package. I can upload any of these like 25 plus package formats, and they can all live happily together in the one package repository. Let's go into NPM. Here it'll show me instructions on how to use this web form to update them, but we're all about automation here. So Cloudsmith also provides you with contextual documentation on how to upload to Cloudsmith. So we have the native NPM tooling that will work perfectly with Cloudsmith. You log into NPM using your credentials and just do NPM publish against your Cloudsmith repository. You can also use the Cloudsmith CLI, which I used in this presentation, but I could have easily used the native tooling. I've been a bit lazy. So you can also use the Cloudsmith API as well. Okay, so I suspect that should be up here now. Okay, so we have our node package. It's automatically pulled in these tags, and during that push, I can tag stuff with whatever I wanted about my CI pipeline. I could say Ciara was here, or this passed this test, or this is the free version, or whatever you're interested in. And if I click into this node package, it's pulled out the checksums, the signatures, and the version number. Who wrote the code should be there somewhere. Some person. Oh, that's my fault. I don't have that information up in my GitHub project. And it's pulled out that it's using Mocha as a dependency. Okay, let's run one more. We'll do a Python pipeline. So I've also forked this from Buildkite, thank you kindly. And this is the pipeline here. So I've built my Python wheel and I'm pushing it to Cloudsmith. Again, yours will be, your pipeline will be a bit more complicated than this. I actually didn't even install the Cloudsmith CLI because I knew I already had it. Forgiveness, but this will work fine. Okay, so I built my Python wheel here, and now I have my Cloudsmith push. And again, I use the Cloudsmith CLI, but I could use the Python native tooling here, no problem. And during this push, like I said before, I can tag extra stuff on my push, or I can just wait till after it's already pushed. Okay, let's go into my, oh, here, I'm already here. This is my Python pipeline. I've set it up to use my GitHub project, my Python project, and it automatically picked up my steps from my Python YAML file. You can also get it, obviously, you know, if you use Buildkite, you can get the builds to run on a commit or whatever you want using Buildkite's web hooks, which is great. Okay, so this is running here now. This one didn't take too long. So I'll go back to my Cloudsmith repository. Oh, it's already built. Wow. And it's pulled out all these tags about the package. We have all the checksum information, version control, who wrote the code, your GitHub, and oh, it's pulled out your license information as well. Cool. Okay, so let's go back to this repository, and I just want to spend a minute talking about multi-format repositories. So, okay, so I have one repository here, and I can put whatever format I want into my single repository. So when I started out in software development in the late 2000s, I was building C++, computer vision apps, and we actually built the UI in C++. Who would do that now? Nobody. So most projects have like at least separate code for the UI and the back end, and you probably use some container, Docker, and something for orchestration. And so you're talking at least like 4 package formats. if it's one project, it'd be so nice for a developer or for anybody to see them all in the one place. It helps you visualize how your code all works together, and you can pretend you can have your mono repo back. I like a mono repo. It's been a while though. So that's just brilliant for a developer to visualize their project as a one project all working together. But as well as that, you can actually control access from this one repo. Loads of different formats, one repo. You can set your edge caching rules, your geo IP rules, your retention rules. So if you only want to store the last 2 versions of a package, you can set that here. There's loads of other things to set here. It's super, like, it's a brilliant feature, and our customers really love it. It takes them a while to get used to it because they're used to, oh no, all my no projects have to go in one repo and my Python in another, but it doesn't have to be that. We're not opinionated about how you organize your project. Okay.
On.
No. Okay, so as I was talking right there, multi-format repositories allow you to store artifacts of different formats in the same place while maintaining compatibility for all native product types. You have a single repository and a single set of processes for managing, sharing, and controlling your software assets. You lose absolutely nothing when it comes to functionality. So you can organize your package repository by environment. This is like a classic way where you have a dev repo, you have a staging repo, and a production repo. You have your dev repo, you set up your upstream, you bring in the packages you use from upstream, you cache them, and then you can check the checksums, the signatures, and maybe run a scanner against your packages and then promote it to the next stage. So some people actually have manual steps during that. They actually want to look at the code that they're bringing in. And you can organize your package by project. You can just have one big repo and then just tag it dev. You can tag your packages dev or staging or production, or you can tag it free, or whatever information you used in your CI. You can just use tags. They're really powerful. Or you can organize your project by package type. Other package managers make you organize your packages by package type. This suits loads of CI processes, but we just don't make you do it. It's a perfect way to organize your package repository, but like we're not opinionated about that. Okay. So there's been loads of changes to software development over the last 10 years. The availability of cloud infrastructure, distributed teams, automated pipelines, and the increased awareness and of the importance of securing your supply chain. So good software need good DevOps tools like Buildkite and Cloudsmith. They need to be cloud native. They need to integrate and automate with other tools. They need to have security by default, and they need to make your DevOps supply chain transparent so you can secure it. We want to make life easier for developers by adding continuous packaging to Cloudsmith to your Buildkite pipeline. It gives you fully continuous pipelines. So that's it. Questions?
Thanks so much. It was wonderful. I do have a few questions that have rolled in. Let's see here. Too many tabs. There's my tab. You have mentioned sort of early on, and I think like we showed some examples of this. So I'm not sure if this person's question was answered, but they were talking, you were talking early on about sort of the importance of making sure package managers are easy to automate against. Yes. What are some of the things that determine how easy or difficult that is?
I suppose people want to use the native tooling that they've used for their packages. They want to use npm publish or like Docker push or I don't know, like they all have their own little things. I know. So that's what I'm talking about. Like we enable you to use the native tooling against our package repository. You can also use Cloudsmith push, and that's perfectly legitimate. Yeah, and we just have strong documentation as well to let you know how to use our APIs, our CLIs, or to use the native tooling.
That's really cool. I know that can be sometimes like a really dogmatic opinion folks have as far as like how much abstraction is too much abstraction, and sort of being able to use those native things, but like in the context of something like CI/CD, like being able to have a universal syntax for dealing in kind of like heterogeneous environments.
Oh, yeah, wouldn't it be brilliant if there was just one? It would be great if there was just one package format, and then like it'd be so much easier.
Yep. So speaking of running your own package manager, we had a question come in asking what Cloudsmith sees as the pros and cons of their solution versus some competitors. And they called out Package Cloud and Artifactory as examples.
I think so Cloudsmith has been architected to be cloud native. And we're like a SaaS tool, and we have like over 230 points of interest across the world. So it's like no matter where you are in the world, we're like really quick and fast to work with. It helps collaboration across distributed teams. And our technology is based on like CDN, and we actually have, we've coined like a new tooling. We like to say a PDN because we have a package delivery network. It's like a CDN, but it has like packaged knowledge on it. So it does a lot of authentication at the edge. And that's kind of important because package managers are actually really chatty. And between your local machine and Cloudsmith, there's a lot of communication going on there. So it's great to put that at the edge to make sure that you have the fastest experience you can have. So fast.
Right on.
And also I think like our support is really excellent. Like other package managers, they limit you to maybe having 2 people interact with support. We don't have that kind of limitation. You just talk to us on Instagram and we're like, hi. Let me fix that for you.
Great.
Okay, maybe I'm over.
Hey, there's something to be said for being folks' favorite folk to work with. I think we got time for about one more. I thought I'd ask, there a couple folks asked about, you had mentioned the Docker image vulnerability scanning.
Yes.
And the question was, what sources does Cloudsmith use to scan those containers?
Okay, so it uses CVEs. That's the vulnerability that it's showing you based on a CV. But it's either, I don't want to name we use like a well-known tool. It's whose name I've has lost in my head, but is it Trivia or Clam? And it provides you the CVE vulnerabilities. Gotcha.
Right on. And I think so we are getting close to the 40-minute mark. So if your question did not get answered, we'll go ahead and collect them and possibly catch you with a follow-up. So we'll reach out to attendees and definitely be sure to come back at 11 o'clock today. We're going to be hosting a webinar with, who are we doing at 11 o'clock? Our friends at PagerDuty. So you'll be joining myself and Mandy Walls to talk about some of our PagerDuty integrations. Ciara, thank you so much for joining us and presenting. That was wonderful.
Thank you. It was my first conference, so I'm just glad to get it out of the way. Now bring them all on.
Excellent. Glad we could be your first conference, and it was a pleasure. Everyone, thanks for joining us, and we will catch you at 11 o'clock Pacific time for our next webinar.